Minutes past. Welcome everyone to the STEM Talk session 3 of the 7th Polygence Symposium of Rising Scholars. My name is Chris and I will be moderating today's session. The goal of the symposium is to celebrate and showcase the hard work that all of you guys have done. Tirelessly worked for on your projects for the last couple of months. We have 3 to 5 student presenters today presenting on a variety of topics. A fellow member of the Polygence team will be scoring each student's presentation for prize winners after the event. As the students present, please, if you have questions and answers, we're going to keep those to the end of the session, the whole session. So as the students are presenting, please type your questions into the Q&A tab that you see in Zoom. And indicate who the question is for. And then once everyone has presented, we'll come back around and I'll go through some Q&A at that time. So we should have plenty of time for that. So today's speakers are Anya Levin, coming from New York City, Aziza Isbekova from Kazakhstan, and we have Arjun, Anilkumar from South Carolina. And there may be a couple of others joining, but right now those are the 3 that are teed up. So with that, Anya, I will hand it over to you and have you start your presentation.
Thank you. All right.
Oh, I'm sorry, 1 second. If the panelists, the other speakers could turn off your audio and video, that would be great. And Arushi, hello. Welcome. I'm Chris. I'll be moderating and I'll call your name after the other 3 have presented, and then you can go through your 8 to 10 minute presentation if that works. Sound good, Arushi? Okay, very good. All right, Anya, it's all.
Thank you. Thank you to everyone who is here. Hi, my name is Anya, and I'm very excited to be presenting to you all today. My Polygenes project was a meta-analysis of the impact of socioeconomic factors on city-level prevalence of Mycoplasma pneumoniae. Mycoplasma pneumoniae is a common upper respiratory pathogen and one of the main culprits behind community-acquired pneumonia, particularly in its epidemic years. In addition to upper respiratory symptoms, Mycoplasma pneumoniae can cause serious extrapulmonary manifestations, including acute hepatitis, encephalitis, and Guillain-Barré syndrome. Because of these complications, treating severe mycoplasma cases is absolutely vital. Mycoplasma pneumoniae is a bacterium, but surprisingly, it does not have a cell wall. This means that beta-lactam antibiotics, which act by damaging the cell wall of bacteria, are ineffective. This, in fact, leaves doctors with a few antibiotic options when treating Mycoplasma pneumoniae, those being macrolides, fluoroquinolones, and tetracyclines. Macrolides have thus far been the standard of care, as they carry fewer side effects, especially in pediatric cases. However, resistance to these antibiotics has been emerging recently, and genotypes associated with resistance have been identified on the 23S ribosome. In many studies, including some of the ones I focused on for my meta-analysis, resistance is commonly associated via PCR genotyping or a certain mycoplasma strain. But in others, a minimum inhibitory concentration method is used. As shown in the image on this slide, a strain is exposed to various concentrations of antibiotic, and the amount that completely eradicates it is called the minimum inhibitory concentration for that strain. Resistant strains have far higher MICs than those that are sensitive to macrolides or any antibiotic in that matter. With that in mind, my research question was, how do socioeconomic factors, including age, median and mean income, access to health insurance, cost of living, impact the prevalence of macrolide-resistant Mycoplasma pneumoniae in US cities? Now going into my methodology, I sourced studies from the PubMed research database via the search terms Mycoplasma pneumoniae and resistant. My study inclusion criteria included a publication date in 2012 or later, a stated city of collection for all samples used, genotyping or MIC to determine resistance, and samples exclusively from the United States. Also, studies were excluded if they did not have an English translation that was available, a case study of a specific outbreak, studies that directly excluded resistant isolates, and those that were themselves meta-analyses because that would double count data and make the study ineffective. All socioeconomic data that I used came directly from the United States Census website. The federal census was used, and because 2020 data is more easily accessible and more modern, it was used over the 2010 data. All of the data from each study that met the inclusion criteria was entered into a spreadsheet and stratified by city. For each city, the number of resistant samples and the percent of resistant samples compared to the total samples was logged. Then the cities were split into 3 groups, East, Mid, and West, along the lines shown in the map on this slide. This was done because previous studies had shown a drastic difference in overall resistance by region, meaning that geographic data would have confounded socioeconomic data had the regions not been split. Some cities were on the border of regions, such as Nashville and Memphis in Tennessee, but because Tennessee is considered to be an eastern state more so than a Midwestern one, I included them in the eastern region. In the spreadsheet, census data for each city was then included across variables that were mentioned in my research question, including cost of living specifically that had to be sourced from the Economic Policy Institute because this data was not available from the census. Now on to the results of my analysis. Some of the most intriguing results came from the East region, particularly those including variables of age and cost of living. Starting with age, as is visible on the chart on this slide, in the Eastern region, a positive correlation was identified between percent of city population over 65 and resistance. Here, the correlation coefficient was approximately 0.95, and for 5 cities for which data was available, the p-value was less than 0.05, making this statistically significant as a correlation. As can be seen from this figure, the converse is also true. In cities with high proportions of children under 5, resistance was lower, and the correlation coefficient was 0.91, with the p-value being less than 0.05, also rendering this statistically significant. This correlation extends to children 18 and under as well. There was a negative correlation between the percent of people under 18 in a city and the level of resistance, with a correlation coefficient of 0.85 and a p-value less than 0.10, which may not be statistically significant in a vacuum, but in the context of the other correlations that are mentioned, it is relevant. Outside of age, the East US region had one non-statistically significant but still notable correlation. As is shown on this graph, there was a positive correlation between cost of living for 2 adults and the rate of resistance, with a coefficient of 0.69 and a non-statistically significant p-value. This is important to note because there were only a small amount of cities that were studied, so this correlation may be more notable when looked at across more cities, but that data was unfortunately not available. Finally, although there were no other statistically significant correlations across the regions, I would like to note the lack of correlation between population density and citywide resistance. The R value was only 0.41, so there was no noticeable correlation between the two. This is important because it actually surprised us and went against what I was thinking would happen in the future, as I'll talk about more in the conclusion section. In terms of my conclusions, I was surprised to see that there was a correlation between percent of a city being 65 and older, because usually Mycoplasma doesn't happen as often in adults. It usually happens in pediatric cases or in kids. So for mutation to be so negatively correlated with percent under 18 and percent under 5, and so positively correlated with percent over 65 is surprising, and may indicate that aging cities in the Eastern US are at higher risk than younger cities for resistance in specific. This may also suggest that in the Eastern US, resistant strains rather than sensitive ones spread more quickly in older populations specifically, indicating that Mycoplasma epidemiology patterns may be different in resistant strains across the board. Although trends from the Mid and West US do not indicate the same pattern, the overall resistance rates in those areas were extremely low compared to the Eastern region, and none rose above 10%. So any correlation would be difficult to identify in those regions, a concern that we had at the start and why the data was stratified in the first place. Population density not being correlated is surprising as well, because as a review study by Burazma et al. Found in 2009, a population density is an important factor in predicting the spread of antibiotic resistance, and higher population density is usually correlated with higher resistance. But that was not the case in this situation. This could potentially be because Mycoplasma, again, is usually a pediatric condition. It spreads mostly in children, and they're usually in close contact all of the time, whether that's at daycare or at school, regardless of population density. Overall, the results of this meta-analysis indicate that future research into citywide age resistance correlations are merited, and that for upcoming Mycoplasma pneumoniae outbreaks, the age demographics of the city effect should be kept in mind when estimating the prevalence of resistant strains. In terms of my interest in future research in particular, since there were only 11 cities that were counted in studies that met the inclusion criteria, I'd like to look further into overall surveillance for Mycoplasma resistance. And that's especially warranted in the Eastern US because of the interesting correlations already found there. Also, as resistance spreads, macrolides may have to be slowly phased out as they become less and less effective, and therefore further trials should be conducted in safe and effective dosages of other antibiotics, such as fluoroquinolones and tetracyclines, for Mycoplasma pneumoniae, especially in pediatric cases. Thank you all so much for listening, and I'd like to thank my mentor, Alvin, for all of his help throughout this project, and my family for all of their support. These are the citations for all of the studies that were referenced, and thank you so much for listening. I hope that this was informative.
All right, fantastic. Thank you, Anya. Very nicely done. Yeah, so of all the attendees, if you have any questions, feel free to put them into the Q&A tab in Zoom, and we'll come back to them at the end of all the presentations and ask Anya any questions you might have. You can put your name in there, or you can keep it anonymous, your choice. So thank you so much, Anya. Very good. All right, next we will move on to Aziza. So Aziza, if you are there.
Yeah.
Very good. So the next 8 to 10 minutes are yours. I will pop back on when there's 1 minute left, and if everyone else can mute and go off video, that would be great. Take it away, Aziza. Thank you.
Can you see my screen?
Yes, we can see your screen.
Okay. Hello, my name is Aziza, and I would like to present to your attention a project, the theme of which is potential CRISPR-based approaches for detection and treatment of COVID-19. And the first reported case of COVID-19 infection was detected in December 2020 in Wuhan, China. And as of August 2022, in total, about 600 million infections with coronavirus have been registered. And of these, 6.5 million have resulted in death. And the coronavirus spread to other countries, affecting around 160 countries around the world and growing into global pandemic. And because of COVID's high pathogenicity and detrimental effect on the human population, it was necessary for scientists to develop special diagnostic and therapeutic techniques to stop the rapid spread of COVID-19 and prevent the mortality rates from rising at the early stages of infection. And the reverse transcription polymerase chain reaction, in short, RT-PCR, is the most common viral infection detection technique, and it became the primary technique for the diagnosis of SARS-CoV-2. And however, due to high demand for laboratory consumables, qualified staff, RT-PCR cannot satisfy the need for rapid detection in current pandemic conditions. And moreover, there is inaccuracy with the test resulting in false negatives or positives. And based on the problems caused by the coronavirus and the lack of effective applied techniques, I wanted to analyze and write a review on available or developing CRISPR-based approaches used for detection and treatment of COVID-19 and other viral diseases. And now I want to briefly tell you about the traditional method of diagnosing SARS-CoV-2. And RT-PCR is considered to be a standard of detection. And in order to perform RT-PCR, samples from patients need to be collected first, as seen on the diagram. And the next step is RNA extraction. And using an enzyme known as reverse transcriptase, the RNA is reverse transcribed into DNA. And then primers are introduced, which are utilized to identify the virus. And the RT-PCR machine cycles between temperatures and that heat and cool the mixture to start and stop particular chemical processes that produce new identical copies of DNA fragments. And the cycle is repeated multiple times, and the marker labels bind to the DNA strands when new copies of the viral DNA sections are created, releasing fluorescent dye that is monitored by the machine's computer and displayed in real time on the screen. And higher fluorescence levels indicate higher DNA levels in the sample. And when the concentration of DNA crosses the minimum threshold, the presence of this viral DNA is detected. And although RT-PCR is currently the standard for detection of SARS-CoV-2, this method has several limitations, and it requires advanced laboratory equipment and educated staff. And in many cases, it cannot meet the high demand for rapid testing in urgent conditions of the COVID-19 pandemic, which makes this process of performing testing on the high scale level time consuming. And CRISPR is relatively recent discovery made by scientists in 2012. And the CRISPR system is the basis of adaptive immunity in bacteria and archaea. And after discovering CRISPRs, scientists made the breakthrough discovery of utilizing the system as a gene editing tool. And despite the novelty of this technology, CRISPR has become the most popular gene editing tool in a short time. And in comparison to other gene editing techniques, it differs in its efficiency, ease of use, speed of work. And also our PCR may be replaced by CRISPR-Cas systems, which have demonstrated their potential to be used as diagnostic techniques for identifying viral nucleic acids. And at the moment, all common CRISPR-based detection applications are based on the use of Cas12a and Cas13a proteins. And first developed in 2016, CRISPR molecular diagnostic tools on Cas12a and Cas13a nucleases utilize the collateral cleavage activity of those proteins. And the process of collateral cleavage activity starts from those proteins using the guide RNA to search for the viral RNA. And after identifying the viral RNA, the nucleus becomes activated and it cleaves all the single-stranded DNA or RNA molecules non-specifically. And the researchers have used this collateral cleavage activity to create reporter probes, and these probes are used to detect viral sequences of interest, making it possible to develop a novel nucleic acid-based diagnostic tool for current infections like COVID-19. And at the moment, methods for diagnosing viruses, especially COVID-19, are divided in two types. And the first type is Cas12a techniques, and those include detector, AIOD CRISPR, and the CRISPR Cas12a ANIR. And the second subtype of the viral detection techniques are Sherlock and CREST. And although each of these techniques has its own characteristics, the principle of their work is largely similar, and therefore I want to demonstrate their mechanism of their work on these two most popular methods, detector and Sherlock. And detector detection process starts from Cas12a protein being targeted to a specific DNA sequence by CRISPR RNA, and this reaction supplemented with specific reporter which will provide this fluorescent signal when the surrounding single-stranded DNA is broken down. And in order to enhance analytical sensitivity of detector and eliminate the need for trained professional and advanced equipment by performing the amplification under isothermal conditions, scientists employ the step of amplifying DNA using specific technique called recombinase polymerase amplification, and its alternative of PCR. And the degradation of DNA probes and surrounding trans ssDNA produces a fluorescent signal, which determines that a particular viral or pathogenetic genomic sequence is present in the sample. And with a 95% positive predictive agreement and 1% negative predictive agreement, the detector assay provides more rapid and visual results than its counterpart RT-PCR. And another method is Sherlock, but instead of recombinase polymerase amplification, it uses another isothermal amplification called loop-mediated amplification. And this method could particularly be implemented as the main detection technique in regions with lack of sophisticated labs and other resources to conduct RT-PCR. And here you can see all the conventional treatments. Those include mRNA vaccine, which is based on mRNA that corresponds to a viral protein, then adenovirus viral vector vaccine, and inactivated vaccines, which are based on inactivated viruses, and the therapeutic treatments like monoclonal antibodies and inhibitors of viral RNA. And there are two CRISPR-based treatment options. And in 2020, one group of scientists have developed a prophylactic antiviral CRISPR in human cells called the Pac-Man in short. And it can target SARS-CoV-2 and other coronaviruses and many other types of viruses. And they identified the effective CRISPR RNAs that could potentially target for their research. And their research led to identification of group of 6 CRISPR RNAs that can target 91% of the available time sequenced coronaviruses. This strategy may serve as a buffer against viral evolution and as a defense against potential new deadly strains of viruses by employing a multitude of CRISPR RNAs. And other group of researchers have developed CRISPR-Cas13d treatment option, and this option is effective against endemic human respiratory coronavirus strains, as well as a variety of SARS-CoV-2 variations, including Omicron. And in conclusion, I want to say that CRISPR systems have been employed in the creation and development of easy-to-use, transportable, accurate, effective, and affordable molecular detection techniques and treatment options. And CRISPR can be a solution to the lack of effective therapies and the urgent need for the development of quick diagnostic tests. And thank you.
All right. Aziza, very nice. Thank you so much for your presentation. And again, for the audience here, if you have any questions, please indicate them in the Q&A, and we'll come back around towards the end of the whole session. So very nice, Aziza. Thank you so much. Next up, I'll pass it to the Arjun Anilkumar, South Carolina. So Arjun, the next 8 to 10 minutes are yours.
Thank you. Sure.
There we go.
Yeah, okay. So a wind tunnel, that was my project. And this is an insight into the process. Before we start, a little bit about me. My name is Arjun Anilkumar from Fort Mill, South Carolina. I'm 17 years old. I go to Charlotte Country Day School in Charlotte, North Carolina. I'm a senior. My free time, soccer, tennis, piano, Model UN. Started a club called Food for Good. And I've always had a long time interest in engineering and math. So a wind tunnel, what is a wind tunnel? A wind tunnel is a device that produces an airstream past models of aircrafts, buildings, and cars. Researchers use wind tunnels to see how things move in the air, or in the building's example, how air moves around objects. Testing allows for safer, more efficient designs to be tested in controlled environments. There are 2 types of wind tunnels: a closed return wind tunnel, which is a closed system of air that continuously flows in a rectangular tube, and the type that I built, an open return wind tunnel, which gathers air from the environment and forces it through a testing area, with the air leaving back into the surrounding. Wind tunnels tested by large companies like Boeing, NASA, and some Formula One teams cost upwards of $15 million and can reach costs of $100 million. So unless one wants to spend millions of dollars building a tunnel, or the thousands needed to rent one, they're pretty unrealistic to people like me who just want to test more often and more easily. My project focuses on making a wind tunnel that doesn't lose the quality of industrial wind tunnels and is more compact, and is made entirely of household items. So the necessary components of a wind tunnel. The most important thing we need is laminar flow. Laminar flow is the term used to describe air that is flowing in a straight pattern with no vortices or turbulence. Laminar airflow is what is going to be experienced by whatever is in the test area, whether it be wind moving past a building or a craft moving through the air at some speed. Firstly, it's important to pull the air through the tunnel rather than blow, since blown air creates a lot of unwanted turbulence. Since the outside air will have still have some turbulence, we also used a mesh that was placed, excuse me, that was placed before the test section. That's right here, we can see that. Additionally, the airspeed will need to be increased through the test section of the wind tunnel using the volume flow rate relationship. Flow equals area times velocity. We can see that in order to increase the velocity, the cross-sectional area of the tunnel must also decrease. It's also necessary that after the test section, there be a diffuser to increase the total pressure recovery of the airflow. On the third picture here, we can see the generic shape of an open return tunnel. The air will flow through in here and out this end. So here we go. What we needed. Following the path of the air, let's look at each individual part of the tunnel. First, we have the opening section right in this top left, which has a ratio of 6:1 compared to the test section at a 12-degree angle. This ensures that enough air is coming into the test section, and the 12-degree angle keeps the laminar airflow from getting disrupted. The test section itself is made of CD cases. We can see that right here, where the model is placed. This hatch would turn out, this hatch right here would turn out to be essential in the function of the wind tunnel. In the first test, I realized I would need to further compress the air around the object. To do this, I inserted a small piece of cardboard. This created a massive zone of low pressure right behind the cardboard. To fill the zone, the hatch opens, letting air fill the area, keeping the laminar air from being sucked upwards, away from the vehicle. The diffuser, as you can see right here, does not touch the fan. After some trial and error testing, I found the fan has vibration strong enough to directly affect the structure of the tunnel. So placing it a little bit further prevented this. Last and probably most important were the visuals. Since we can't see the air, I used smoke from incense sticks to see the aerodynamic effects. It was also important to have the right lighting, something I learned the hard way after numerous failed tests. A dark room with a singular source of light behind the tunnel, like this right here, seemed to work the best. So now let's look at some of the results we can see. I'm about to show you guys a little video of the wind tunnel. You can see in the area right above the car, right over here, air is being forced up and over the car. In the racing industry, this term is known as downforce. Since every action needs an equal and opposite reaction, the air being pushed up pushes the car down as well, increasing the friction between the ground, excuse me, and the tires. Now let's take a look at this video. And then one more time. So we can see air is being forced up and over the car in this area, which in turn pushes the car down, increasing the friction between the ground. Next, we can see an example of classic drag. There are two types of drag. The first, more obvious drag, is seen by air particles moving around the car. This is called frontal pressure, which is why we associate fast cars with more aero-like noses. There's also a more subtle form of drag called rear vacuum drag. While the car moves right through the air, while the car moves right through the air, there creates a sort of vacuum right behind the car, which can't be filled by air passing over. In the video, you can see clear streams of air over and under the car, but in between there's a turbulent area of low pressure. This low pressure contrasts with the high pressure in the car. And since air moves from high pressure to low pressure, it will drag the car backwards, slowing the car down. And this is the next video. So we can see the frontal pressure here and right above. And then if we look right in this back corner, I'm going to play it one more time. Right in this back corner, you can see some turbulence air moving in like a circle. And this gap right here is low pressure. And that low pressure contrasts with the high pressure in the front of the car and drags the car backwards, slowing the car down. So yeah, just to wrap up, we talked about exactly what exactly a wind tunnel is, the two types, closed wind tunnel and an open tunnel, like the one that I built. Then we talked about the necessary components, laminar airflow, increased wind speed, and a diffuser. Finally, we looked at the results. where we can see two major aerodynamic effects, downforce and drag, both frontal and rear vacuum. Finally, I want to thank my mentor, Thomas Lee. Very big help he's given me. Thank you, my family, friends, and yeah, thank you for giving me the time.
All right, Arjun, thank you so much. Very interesting stuff, and thanks for showcasing all your hard work the last couple months with us. And the attendees here, yeah, if you have any questions for Arjun, please put them into the Q&A tab in Zoom, and we'll come back around after the presentations and ask a series of questions. So thanks, Arjun. Now we'll go to our fourth student presenter, Arushi, Kaushik-Chandra. Arushi, a quick question for you. Where are you calling from?
I'm calling from, I'm sorry, I'm not quite sure I understand.
Oh, where are you located?
Oh, I'm located in New York.
Okay, very good. Cool.
All right.
Another New York student. The next 8 to 10 minutes are yours, and take it away.
Lovely. All right. Can everybody see my screen? Okay.
Yes.
So hi everyone, and welcome to my presentation on the impact of celebrity influence and parasocial love on consumers' relationships with brands. So here's some background to this. Right now, there's a daily exposure to advertisements with around 62% of the global population being on social media networks. And there is now a conflation. Usually we see celebrities in the media and the parasocial aspect of that, going into the parasocial aspect of that, but we've never seen that in brand marketing. The most that we would get prior to the past decade was celebrities making an appearance in advertising. But now with celebrities launching standalone cosmetic brands, they essentially become a core identity of the brand. And so there's a lot of interesting things to be discovering when we're analyzing the parasocial aspect and the psychological aspects and implications of doing so. So if none of these things make sense, I'm about to go into a couple definitions that are going to contextualize the rest of my presentation. So here, I have a couple definitions. First off is parasocial love, which I've already used a couple of times. It is affection or affinity to a piece of media derived from the individual forming a one-sided relationship with that media. It can be developed with any form of media, but especially social and digital media, as this presentation focuses on. And then there's customer citizenship behavior, a set of behaviors that customers do to boast the social and physical credibility of a brand they like. And as it's relevant to the survey, this involves intent to purchase and spreading positive word of mouth about the company. Previous research indicates that customer citizenship behavior and positive word of mouth are likely to occur if the consumer has a positive parasocial relationship with the media subject. So when we were formulating the survey, we had to decide upon some criteria upon which to analyze consumers' relationships with these brands. So we ultimately decided on positive word of mouth and intent to purchase the product from the brand. And so going into the literature regarding these brands and their parasocial interactivity, where the literature currently stands, direct celebrity involvement in brands itself has not been studied much. Lebrecht studied how certain digital behaviors can make a brand appear friendlier and result in higher self-reported scores on scales that measure parasocial interaction strength. In a similar vein, Kim et al. Investigated how certain behaviors and campaigns that appealed to customers' emotions and morals affected the respondents' self-reported perception of how good that brand is. In this sense, the current literature investigates whether behaviors affect perception. Celebrity-owned brands are a relatively new trend, and as such, there isn't much in the way of studies that investigate how celebrity affiliation with these brands itself affects the perception of these brands. So Now going into the study overview, the aim of the study was to investigate how the incorporation of a celebrity in the marketing of a brand influences an individual's perception of the brand. We predicted a positive association between celebrity incorporation within a brand and presence and intensity of parasocial interaction. We also predicted a positive association between parasocial interaction and intent to purchase and word of mouth related to that brand. So going into the results of the survey, here's just a sample of the demographic. As you can see, the mean was around 19 years old with standard deviation of 8 years or so. The gender demographics are over here, with it being predominantly women that ended up taking the survey, and then race demographics here. One thing to note about the education demographic is that the way the question was phrased, it was please report your highest level of completed education, which contextualizes the elementary or middle school being the highest reported frequency, as it would indicate that the majority of respondents had not yet completed high school. So here are some of the measures that were taken in the survey. 27 participants took the survey across 17 days, and questions were asked on a 5-point Likert scale, with 1 being strongly disagree and 5 being strongly agree. The scales used to measure these variables were the Celebrity Persona Parasocial Interaction Scale by Bocarnea and Brown, the Parasocial Interaction Scale by Rubin et al., the Audience Persona Interaction Scale by Author and Palmgreen. The purchase intention was measured by Jester and Kumar et al., different scales respectively, and word of mouth was measured by Carroll and Ahubia. So some of the sample items that, this is what the survey looked like. This is a sample of some of the questions that we asked, where I see the brand as a natural, down-to-earth brand. I'm looking forward to using products from this brand. The brand seems to understand the kind of things that I want. And what's interesting is that there was a lot of overlap in and sometimes identical wording, except the only difference was that the question was talking about the brand or the question was talking about the celebrity itself. So as you can see here with the first and last item, that there was some overlap in these questions. So here were some of the survey prompts and just an idea of what it looked like. We used 4 different brands, 2 having product ambassadors and 2 being faceless brands, so to speak, in the video that was shown in the survey. And so we analyzed it using SPSS with ANOVAs and regressions to look at the relationship, the associations between the variables, and analyze the results. And so then the results were that we actually found significant differences with each brand. Individuals reported higher levels of parasocial love towards Rihanna, or the brand that Rihanna was associated with, or Fenty Beauty, compared to MAC Cosmetics, which was a faceless brand, and Bite Beauty, which had a human ambassador, but not Tarte Cosmetics, which was also a faceless brand. Individuals reported higher levels of positive word of mouth towards Rihanna or Rihanna's brand compared to Bite Beauty, but not MAC or Tarte Cosmetics, and individuals reported higher levels of intent to purchase towards both MAC and Rihanna's brand compared to Bite Beauty, but not Tarte Cosmetics. So ultimately, here are some of the statistics from the regression, with parasocial love being positively associated with word of mouth and intent to purchase for all 4 brands. So the p-value was significant. But for only Rihanna's brand, did a celebrity persona interaction signify a positive association with word of mouth, but it also signified a negative association with intent to purchase. This result really surprised us, as this wasn't something that we predicted, but thinking about it, contextualizing it, that intent to purchase might not always be correlated with a beauty brand, because the realistic price range for these products may be quite expensive. So while a individual might experience a lot of adoration towards a celebrity and view the brand in a good light, they may not necessarily be inclined to purchase the product because of those kind of financial limitations. So these were the findings that we found, and which supported the positive association and our predictions with this study. So here's some discussion and limitations. So first off, regarding the sample, the size was relatively small with only 27 total respondents, and individuals were exclusively from the USA. Additionally, discrepancies in replications of this survey done in countries other than the USA may stem from different cultural norms, differences, and perceptions of celebrities. Furthermore, there was a limited selection of brands, with only 4 brands being selected, and a different awareness of certain brands and celebrities, as inherent with just general social awareness of these brands, which is also ties back into the survey being limited to the USA. Finally, discussion in the broader community studying this topic, some debate in the field over using scales by Rubin et al., claiming that the scale is outdated. And so in replicating the survey, while adapting different scales for the same metric of parasocial love, that would be beneficial in perhaps yielding more insight into that if that ended up being an issue. My citations are available on request, and I would just like to take this moment to thank my mentor, Jacqueline. She was a huge help in this process, and I couldn't have done it without her. So thank you for listening to my presentation, and if you have any questions, please let me know.
All right, Arushi, thank you so much. Very good presentation. And again, for everyone here, if you could go ahead and put any questions you have in the Q&A. That wraps up the presentation part with about 12 minutes left. And so I'm going to go ahead and move to a series of questions that we have. In 1 second while I remove this spotlight here. There we go. All right. So wonderful job to everybody. Thank you so much for compellingly and clearly articulating all the hard work you guys have done over the last few months. I want to come back to Anya and ask you, Anya, what was the original kind of inspiration? What inspired you to start on your project? What was the core of it?
Yeah, so this is almost like a joke within my family that I kind of have a vendetta against Mycoplasma pneumoniae in specific. I got Mycoplasma pneumoniae as a child, and it can trigger some neurological consequences that I ended up having. So I ended up doing a little bit more research into that and fell down a bit of a rabbit hole. So I've been doing research in this field as like review articles for about 3 years now, and this is my first meta-analysis.
Got it. Okay. So from deeply personal experiences. And then a question here is, I guess, is there an opportunity to do another study kind of more at the neighborhood level rather than the city level, given the diversity within neighborhoods? And is that something that you're interested in?
That would be fascinating. The only concern is that this is a very under-researched field that has been chronically underfunded for a few reasons, including the fact that there's not a lot of profit to be made in terms of finding new antibiotics. We're really looking at resistance because a lot of the time resistance affects communities that are not like represented within the hospital system, and also because resistance is a one and done cure. It's not a treatment that can consistently go on. So because of that, there were only 5 studies that even met my inclusion criteria, and none of them looked at neighborhood level resistance. A big part of that as well was because this is an endemic condition, so it comes in waves and it comes and goes. So if one strain happens in a neighborhood, then basically everyone in that neighborhood has that one strain. There's not really a variation there. So it makes looking at narrower sample sizes a little bit harder.
I see. Got it. All right. Well, thank you for that. Move to Aziza. Question here on, I guess it'll be a common theme, but what was your inspiration to study for your project for COVID and CRISPR?
Yeah, I think in my case, it's more straightforward because obviously there is a pandemic and I also had COVID-19, and previously I had done research on CRISPR-based techniques, but for other types of diseases. So I just wanted to find more information about COVID-19 in particular. So, yeah.
I see. And is there something here that you plan on continuing to study with respect to CRISPR?
Yeah, since my research is not exactly like research, it's more review. I want to actually have just this part of practice, and I want to do a lab research if I will have an opportunity to do so. Yeah.
Got it. All right. Well, thank you so much. Question for Arjun. Yeah, what was the inspiration for creating a wind tunnel?
Well, I mean, I've been interested in building things for a long time, and a wind tunnel specifically. Well, I'm really into Formula One, and being an engineer for Formula One team is like a dream of mine. So understanding more about aerodynamics, which is just one of the many things that goes into a Formula One car, was kind of an inspiration for me. And yeah, I also wanted to build things and learn and enjoy the process, and I definitely enjoyed it. So I think I'll definitely be doing more of it.
Awesome. And then a tactical question here. How did you color the air so that you could see it in the video?
So that's actually smoke.
Okay.
It's smoke, and it's not like colored smoke or anything. But like the lighting, I did say, and I like mentioned that the lighting was a hard bit, but that if there's no lighting in that, then you can't see the smoke. It's just there's nothing there. So yeah, lighting was definitely something which I mean, not many people would expect to be that important. I didn't expect it, and it was definitely important. But yeah, once you get the lighting right, the smoke right, it just comes together. It's really nice.
Yeah, got it. Okay. And was there what was kind of the most surprising thing for you in doing the project?
Like regarding the wind tunnel, or
So like
I
a
think
surprising learning or an insight that you got from building it, or a surprising challenge?
I didn't think. I think most of my time was spent on like the trial and error part of the thing, part of the process. Building it wasn't too hard. It's just measuring and cutting. But then there's so many like little things that you're like, okay, move the fan a little bit, maybe change this. So many variables, which you don't think would affect anything, but they do. And then once you finally can figure it all out, then it's a very set in stone kind of, it's done. That's how it is.
Yeah, got it. Cool. Well, thank you
Yeah.
so much. And then Arushi, very interesting topic you chose as well. What was the inspiration for you? Was it a specific celebrity in a brand, or what was the genesis of your project's idea?
So I actually took a remote class in psychology last year, and my final presentation was something very similar, and they asked me to choose a topic, and I just stumbled across this topic and I gave my presentation, and I found the topic so compelling that I wanted to pursue it further and take it in and make my own experimental design because I just found it so interesting that I wanted to keep returning to the topic even after the semester finished.
Got it. Are there any having done this study, I'm guessing you have your eye out on the media landscape. Are there any current kind of celebrity sponsors that have caught your eye and you feel like, oh, the brand did a good job matching that celebrity with the brand?
I would say that I actually deleted social media a while ago, so I wouldn't be able to give an updated response. But I think that one thing that I explored in my study was the way that it was phrased. So there was like what was really impactful for me is that like one of the characteristics of the advertisements that featured like the celebrity, it would be like Rihanna or like in the lab or whatever, and she would be saying, I created this product for you. I wanted to create a product that all of you could enjoy, adding that personal touch. And the way that dialogue really appeals to that personal aspect, despite it not really being like, truthful or accurate. So I think that that kind of thing to look out for, especially in like when you see advertisements, but it's definitely opened my eyes up to like the way that it's a very like subtle but very impactful way that they maneuver celebrities in advertisements.
Yeah, definitely. All right, thank you very much. I'll just kind of open it up here over the last couple of minutes. Is there anybody that just wants to ask a question live? The panelists, you guys can ask each other questions, or any of the attendees can you simply raise your hand or just start talking.
Arushi, I actually had a question for you, if you don't mind.
Totally.
So in terms of your study design, when you were thinking about how you were going to spread the survey, did you think about any other like platforms that you would have used to kind of get the word out about it? And would you consider posting it on social media for that purpose?
Actually, I did consider other platforms, but when I realized that I wanted to keep the limitations of this survey within the USA just for, control factors, especially when we're looking at, the way that people respond to, the things regarding psychology. Psychology has a lot to do with like the socio-cultural factors. So I wanted to keep it to the USA, which is why I didn't really promote it on the online platforms. I did promote it on my social media, like privately on my private account with people I knew. And it's funny actually, because I was at a music camp at the time and I actually just went up to people personally and I was like, hey, can you take my survey? It only takes 10 minutes. And I'll kind of like hover over them while they completed it. So a lot of the respondents just took it in person rather than digitally, like over social media. So if that makes sense. So yeah, thank you for your question.
All right. Very cool. All right, got about 2 minutes left. I guess I got a question for Anya that I didn't get to ask before, which is you kind of alluded to it, but for you, what is next for you on this topic? Like, what do you anticipate the opportunities for further study are?
Yeah, so within the field of antibiotic resistance for Mycoplasma specifically, I think the next step is to look at what's happening with fluoroquinolones and tetracyclines and say, can we use those as pediatric treatments? If so, to what extent? And if so, how long will they last? That's where my interest comes in, to do potentially an in vitro look at how long it would take of just, selective breeding to get a tetracycline resistant or fluoroquinolone resistant strain, which currently doesn't exist. See how long that would take, and then pull out an estimate of how many years we have before those don't work either. And we need to look for a new antibiotic overall.
Got it. Okay. That gets to the heart of the issue, right? And how you can help it to use to help kids. Very cool. And then I guess with 1 minute left, I had one final question for Aziza. Some of the other presentations answered this as well, but what was the most surprising thing, Aziza, from your research that you found?
Actually, the fact that there is opportunity to treat COVID-19 with the CRISPR technologies, because even my mentor didn't know about that, and she studies this topic in depth. And I think that was the most surprising thing. And usually it's treated with like monoclonal antibodies or just a therapeutic treatments, but just using gene editing tool is something new and novel.
Got it. All right. Cool. Very well done. All of you fine folks. So thank you so much for sharing your insights with me and with others. Yeah, stay tuned. We got about 5 minutes before the keynote presentation. So I will end this session now. And we can take a quick break. If you're back, maybe join us in the lobby. And we'll see you in 5 minutes for the keynote. So thank you very much.